Let's take a look at our first example, and remember that the number one first thing to always look for is a greatest common factor. As I look at these three terms, I notice 1, -4, and -5 don't have anything in common. However, I have x's in every single term. How many x's in common? Well, the one with the smallest exponent on it. So just a single x is in common to all of them. The others have more, but that's the only one in common. So I'm going to write this monomial factor, or this GCF, out in front, and then remember to write the rest of what's left. We divide by our GCF. So x to the third divided by x is x squared, followed by -4x when I divide x squared divided by x, and then -5x will become a -5. So the step that we just did was GCF, and I'm going to be writing this step out to the side so that you can remember later what you did to get that line. Next, I'm going to look at how many terms I have left. I have 1, 2, 3. If you want, you can take a peek up at your diagram. Is going to help you until you become familiar with all of these factoring methods. So if we have 3 terms, we know we're going to be using some sort of quadratic form from our flow chart. And so let's take a look at this. We have an a value of 1, so that means that we can use the simple method of asking ourselves what 2 factors will multiply to be -5 but add to be -4. So let's go ahead and set this up. We know we'll have x's in the front, and -5 and +1 are the ones that are going to fit that criteria, -5 and +1. So that is just factoring a quadratic that we had left after we took out that GCF. All right, we need to ask ourselves if we are done. We are done when we see a monomial factor. We can't do anything else to that monomial factor. And if we see a linear factor, linear meaning that it just has an exponent of 1, if we see a linear factor, each of these is done as well. If you see something that is more than linear, so quadratic, a 3 or 4, 5, anything like that, you need to see if you can factor it further. So use your flow chart until you are not needing it anymore. See if you can factor it. If you can, do that. If you can't, then it's not factorable and you are done. All right, this time I have 5z to the 4th plus 30z cubed plus 45z squared. And again, first thing I'm going to ask is, do we have a GCF, a greatest common factor? And this time we have both a number and a variable that's a greatest common factor. I see 5 and I see z squared. Once we take that 5z squared out and divide each term by it, since we're bringing it to the front, we can say that we have z squared plus 6z plus 9 as what's left. And again, this is just GCF. I see that I, again, have 3 terms, so we're going to be doing our quadratic form. And since a is equal to 1, we are simply going to factor our quadratic again. So this time, we are looking for factors of 9, so 2 things that multiply to be 9, but they add to be +6. I can put my z's in front, and 3 plus 3 is 6, and 3 times 3 is 9. So that's going to be my factor in both places, 3. I can rewrite this in just a little more simplified terms if I say z plus 3 and then square it, because notice I have a repeating factor here, the same factor twice. So this is just a simplify step. Let's look at this next one. We're getting into something a little different now. The first thing I notice is that there's only 2 terms here. But before we get into what to do with that, we want to look for a greatest common factor. 3 will divide into 48, so I'm going to pull that out, as well as a y to the 3rd out to the front. Dividing both terms by 3y cubed, I'm going to have y squared minus 16. So that, again, is starting out by pulling out a GCF to the front. So I have this, what we will now call a monomial factor. It's a single term, and it is a factor. It's our greatest common factor. Now we want to look at what's left. We have a y squared minus 16. So let's think about y squared and a 16. And take a look up here at our flow chart. We have two terms left, and the operation between them is subtraction. We want to ask ourselves if both terms are perfect squares, perfect cubes, or neither. And I have a y squared, that's the perfect square of y, and then 16 is the perfect square of 4. So I do have subtraction, and both terms are perfect squares. I'm going to use difference of two squares to factor this. And so looking at my difference of two squares to remind me what it looks like, I take the squared things and take the square root of them. The a value goes in front, b in the back, positive, negative, one of each. So let's do that. 3y squared just kind of comes along for the ride, and the square root of y squared is y, and the square root of 16 is 4. So one of them needs a plus sign and one needs a minus sign. So this was difference of two squares. And now I'm ready to ask myself if I'm done or not. So difference of two squares here. And let's take a look. I have a monomial factor. That's done. I have a linear factor because I have an exponent of 1 and another linear factor with an exponent of 1. So that means that I am done. I don't have anything else that I can do except box this as a final answer.